And we're back. It's just so quiet. Okay. Thanks for the questions. There was some discussion about IDEs. I use VS Code, but I don't know how to do the fancy debugging stuff that Marius has set up. Sergey, are there notes about how to do that somewhere? Oh, there, yeah. Cool. In the docs. Awesome.
I just linked them, yeah.
Cool. I should read them. All right, let's keep going. Now we're getting into the back end properly. So again, coming back to this diagram, it's all the stuff to the right of manager here, essentially. So there are many different ways to sort of describe or visualize or think about the backend architecture. But sort of for the sake of these slides, the way I sort of am visualizing is that that all this stuff, like the ultimate source of truth for all Galaxy stuff in quotation marks here is like the database, right? So there are things that are external services that aren't the database, but the database is the sort of primary thing, and so it's the ultimate source of information. And the API controllers are the ultimate sink. That's where we're sending information out. And so it's not a perfect visualization of the backend, but it's something to think about. But in that visualization, maybe the flow of data through Galaxy looks like this. We've got the API, which are controllers. They talk to managers, which talk to all the different application components. Most of them are going to talk to models and to the database. So the managers mediate access to the backend and the components, and then the models mediate back access to the database. And so in this sort of representation of Galaxy, managers and models are very important things at the top and the bottom of the stack of the backend. But this is in certainly imperfect visualization, but it's just something to consider. One way of looking at it. So managers are basically contain high-level business logic that ties all the components together. So, I should mention, in terms of packaging, right, if managers have to talk to the whole backend, then these two layers here are the app object, or the app package. So Galaxy-app. And this is Galaxy data. And you can sort of see app depends on data, which we saw in that diagram. And then this is the web apps. And so web apps depends on app. And so this is that package. This can sort of be seen as that package diagram also, a package dependency diagram. So maybe you've used models in another sort of web framework before, and you sort of might ask, when do I use a model and when do I use a manager? And the way I think about it in terms of Galaxy is that those models should just depend on the database and the data that's in the database. And I mean, like, you know, requests that are being made. I mean, like the actual method parameters or like the input data, right? Like that's something different. But like the model shouldn't depend on other random Galaxy components, right? And so if your operation requires you to do something with the Galaxy workflow scheduler and then save something to the database, well, then that doesn't depend in the model. That doesn't happen in the model. Maybe that saving it to the database part happens in the model, but not something that's talking to another Galaxy component. So yeah. So if it requires more than just the database, you should probably have a manager for it and not a model. Or another component that's sort of serving as a manager. But the managers are in libgalaxy managers. And so there's a bunch of different managers for different components of Galaxy. So users have a manager, data sets, histories, workflows. But then there are some like other things you might not think about, like citations have a manager. We have a manager that deals with configuration. So like exposing Galaxy's configuration via the API as a manager. So it's stuff that's in the database and stuff that's not in the database. But these sort of top-level files, I think, make some sense and correspond to specific Galaxy objects. There's some helpers that they use. So base is like a bunch of mixins for building managers generally. Context.py sort of is what builds up that Galaxy web transaction we talked about. Sometimes you want a transaction in the backend that describes which user is running the job, for instance. And so the context is a description of the web transaction that's not tied to web pieces. And then there are some more mixins beyond what's in base.py. So Galaxy objects, for instance, many different models can be tagged by the user. And so we have common logic for tagging things in taggable. Many different objects can be secured. Like this object can only be acted on by the owner of that object, for instance. And so, we've got, yeah. So the attributes that are common across those objects are managers are in here. Yeah, and so that is managers. I mean, otherwise managers are really just like Python things. They're really just simple Python objects. At the other end of the spectrum, we've got the models. The database interactions are powered by SQL Alchemy, which we've already mentioned. So since we use SQL Alchemy, which is an object relational mapper, we generally don't think of rows in the database, but we think in terms of objects. And so that's what Alchemy does. It maps the rows to Galaxy objects. Classes for Galaxy model objects are in libgalaxy model init. And then that mapping file is what sort of tells SQL Alchemy how to take a row in the database and turn it into a model object. And then it also describes the relationships and the table definitions. So these two files are huge. And if you're adding new concepts to Galaxy, you'll probably touch both of these files if there's any sort of database portion of that new concept. Yeah. Here's a breakdown of SQL Alchemy from there. I probably should have a link. But they got that object relational mapper at the top, but then also we use some other topics. We use some other parts of SQL Alchemy too that the object relational mapper also uses. So we use the engine, and there are places where we talk to the database directly using the engine. And then it has a nice SQL expression language that is safer and prevents SQL injections. And so we use both of these different components also. So if you've ever sort of upgraded Galaxy from a release to another release, you have to migrate the database. And so we describe, since that Galaxy is a thing that changes over time, our database description is defined in part as a sequence of diffs we apply to the database. And so we use SQL Alchemy migrate to do this. And so every time you want to make a migration to the database or change it in some way, make a diff to it, you stick a file into libgalaxy model migrate versions, and the name of the file should be prefixed with just the next version after the previous one. So I think we're into like the 140s, 150s now. Yeah, and hopefully these files are pretty straightforward. Nicola this last year has done a lot of work to sort of simplify and make these a lot more consistent. So we almost have another high-level framework language on top of SQL Alchemy Migrate at this point, which is nice. It should be pretty clear to like figure out how do I add an index, how do I change the name of a column, how do I add a table, and we've got high-level concepts for all of those things. Here's the database diagram. You'll be quizzed on this at the end. Hopefully you have it memorized. All right, excellent. See, you're all sitting there laughing hysterically at my jokes, and I don't get any feedback. I don't know about this platform. But no, I will break it. I'll break down and talk about some of the individual pieces here. But I mean, many of these models you'll never care about. Probably many correspond to concepts we don't even care about anymore. But I'll go through a couple of the major ones. So histories and data sets are pretty much, well, history data sets and jobs, in fact, are pretty much the most core concepts in Galaxy. The history is that thing on the side bar when you first land on galaxies in the analysis mode, and data sets are the major thing you put in histories, and jobs are what happens when you run tools. If you share history with another person and they import it, then they have their own copy of all the data sets. And so we don't want to copy all that data, but we also want to give them the ability to change the data types or rename objects, etc. So we don't actually want to put the data sets directly in the history. We put them in via history dataset association object, which is another column in the database. I mean, another table in the database. And we will clone all the history dataset associations. So that person has their own copy of the history dataset associations. And they can rename all they want. But the datasets then, there's still only one object that corresponds to the actual physical dataset. And so the dataset, so you may ask, what's on the dataset and what's on the history dataset association? So the history dataset association is metadata that might change, and the dataset is attributes about the physical file on disk, or more realistically in the object store. And so you can have any number of history dataset associations that map to a dataset. You've got the HID, which is the position in the history. History ID, dataset ID. We've got a state corresponding to the history dataset association, the name info, a lot of other stuff here. Whereas the dataset is more like the file name, which object store it belongs to, the file size, things that aren't going to change. So think of maybe datasets as immutable and history dataset associations as immutable. Then there's dataset metadata, which is sort of driven by data type definitions, which are key value pairs that are stuck onto the history dataset association. And they can be used by tools to dynamically control the tool form. That was the story before collections, and we added collections. And so histories can now have any number of history dataset associations, but also any number of history dataset collection associations. And these objects both have HIDs, and they both have a history content type. And the history content type for the dataset collection, the HDCAs, is dataset collection, and for the HDAs, or history dataset associations, it's dataset. Yeah, and so what is a history dataset collection association? Well, like we have this dichotomy between datasets and history dataset associations, we have a dichotomy between the association and the actual collection backbone. And so the collection backbone, again, might belong to multiple history dataset associations and should be thought of as more or less immutable. Oh, so this is wrong. This is 1 and 1. This should be star here. I want to make a note of that somewhere. But yeah, so the immutable part of the collection is the collection type and then the elements of the collection. And each element of the collection can either be, they're nested, they can be nested, right? So the elements could be another collection, or it could be, it could have history dataset associations in that. And that is collections. They're a lot more complicated than just history dataset associations, but that's what the models look like. Yeah, and even this is pretty old. We now have, yeah. There's more to this. This is not wrong, but there's a lot more. I guess we only have so much time. That's things in histories. We also have workflows. You may notice that you can change a workflow, for instance, in Galaxy, but we don't let you, but we store the old workflow. So we have, in order to accomplish that, we have two concepts of a workflow. We've got the stored workflow, which is the thing the user sees in the history, or not in the history, but in the UI. And then we have the actual workflow descriptions, which every time you save a workflow, we have the older descriptions of the workflows. So if these had like numbers here, it'd be like the workflow corresponds to a single stored workflow, but the stored workflow has any number of workflows, including the latest one. And so that's how we keep track of the history. The workflow corresponds to any number of workflow steps. And then we'll talk a little bit more about workflow modules later, but these aren't a database concept. These are the things that sort of implement workflow steps in Python. And so that's the definition. And then when you go to run a workflow, things get more complicated. We've created a workflow invocation corresponding to that workflow, and each invocation for each step has workflow step invocations, which is an implementation of the workflow step. Generally, these correspond to jobs that produce data sets. Yeah, so these are the objects that are resulting from the run, and these are the definitional objects. Libraries. Yeah. So we have libraries in Galaxy. You probably use them. They have any number of library folders, and then they have library data sets underneath the folder. Sort of like collection. We've got a hierarchy here, and the library data set. So there in histories, it's easier because you have a history and then an HDA and then a data set. But here we have a level of indirection between the library folder and the library data set association called the library data set. And this is because in older versions of the library UI, you could replace the actual data set implementation for a particular item in the folder. I think in the UI, we've sort of collapsed these two concepts. I don't think we allow versioning of data sets anymore in the UI. But if you're ever in there and wondering, like, why is it library data set association, not just library data set association? That's why. And so what attributes are here and what attributes are here are kind of complicated, but you could think of these two together as an HDA. And the combined set of metadata should look a lot alike because they're sort of encompassing a very similar concept. But they do have an association with the data set the same way. And so that part is the same. And then we have permissions with roles and groups on library folders. And actions. I mean, this could be another 30-minute talk, and I don't have the slides or knowledge to sort of go into that. I have to relearn it every time I touch that code. But those are at least how the concepts are. You know, a role has a number of user and groups, and then library permissions, you know, are attached to roles. And then data sets, library data sets, and library folders can have library permissions. And that's the models. Yeah, the next part takes 45 minutes. So I won't be, so I don't think I can go into anything more there. But are there questions about the models or managers? I think I saw a question, what's the action? Did I see Martin? Does Martin know what an action? I think it's like, I don't even really know here. No, it's like the, like, can I manage the library? Can I add things to the library? Can I modify the permissions of the library? It's that interface that has the different kinds of things you can do with the library. I think those are different action types. All right, I'm gonna go on unless someone interrupts. So this last part is the longest video on YouTube, and I did the video and then I just like collapsed in exhaustion because it's I don't have a good way to talk about it. We have this big app object that we just hang a million different components off of, and the only sort of idea I could come up with how to like view them in any sort of like structured way is to sort of think they're all like plugins. And so we have different kinds of plugins, and it's just, app just has a bunch of different plugins on it. So it's all of this middle layer here. You know, all of these have plugins. And so I'm like, how can I categorize those plugins? Well, there's a couple different, and so I came up with some I don't even know how to like talk about the architecture here because there's not an architecture, right? It's just a bunch of different things. But the plugin types, I went through and I tried to like put all of the different plugins in Galaxy. I didn't even get all of them, but and then I broke them into like 4 different categories. We got the externally defined ones, which we've already talked about, the SQL Alchemy backends and the middleware. Those interfaces are defined externally. And then we have some plugins that are places where we just use inheritance as a plugin structure. So if you have a base class that you can subclass with specific with specific behaviors, that is a plugin, right? And so an admin may want to define a new object store. And to define a new object store, well, we don't have any sort of dynamic code loading. We just subclass object store and we put it in a big dictionary with all the other object store implementations. And so some really important ones just use inheritance. So tool classes, workflow modules, object stores, metadata collection structures. We just have an inheritance structure, I mean, a base class, and you can subclass it and stick it in a dictionary, and that's a plugin. We have a lot of plugins that use, at some level, some custom code loading, and that's done in Galaxy. And so these are more like proper plugins. We've got the controllers we've talked a little bit about. We'll talk about data types here. Tool instances, you take those tool files, each of those XML files is a plugin to Galaxy with its own sort of, and you can think of the loading that tool file as some sort of custom code loading because those tools have logic in them. That is code loading. Visualizations, data providers we'll talk about in a little bit here. Tool parameters, dynamic job destinations. The training material around admins has a description of how to implement those and some common examples. Web exceptions, we load from a JSON file, a description of all the sort of exceptions we can throw in Galaxy. Tool actions, you can specify the tool action to load in the tool file, and so that's a sort of custom code loading. And then toolbox filters. Again, there's another thing that admins might care about. And then we have plugin config plugins. So we do have a sort of plugin framework that we reuse over and over. That provides a sort of consistent interface in how the admin might describe how to configure the plugin, and then how the developer might implement the classes of the plugin. And so we use plugin config in the util package, and then there's a related file in there called submodules. And the idea, well, we'll talk more about it. But authentication is done this way: job metrics, tool error reports, tool dependency resolvers, container resolvers, workflow schedulers, tool linters, tool test assertions, all sort of just load all the files in a directory and make a plugin definition out of those. And so the rest of this talk and the rest of this section is just me talking about a few different of these different components of Galaxy. A big one is data types. Oh, I had a to-do item. We have to have some documentation somewhere about how to define custom data types, but and I should be linked here, but it's not. But all of this code is in libgalaxy data types. We've got the registry file in there, which is, from a framework perspective, probably the most interesting file. It's the framework code for finding, configuring, and loading data types. So this is the most interesting file there. Data, text, and binary are the base classes for different actual implementations of data types that you might want to use. Data has the base for everything, for all of them, and then depending on whether it's a text or a binary, these are worth looking at. We've got some simple base and actual implementations of data types in text.py and then binary. Otherwise, we have them broken into different files, sort of sometimes by topic, like genetics, and then sometimes by application, like BLAST, or assembly is a big topic. So that I don't know that we have a great organization of these, but it probably, based on the file name, is clear what kinds of data types are in there, hopefully. And that's the data types package. It's a commonly modified package in Galaxy, so it's worth talking about. Let me just see where we're going. Yeah. After that, tools and jobs are a huge part of the Galaxy backend, and it's worth talking about. The three major sort of classes in the backend architecture that revolve around tools can be thought of maybe as this way. The toolbox contains tool objects that execute a tool action. And here is that. So the toolbox contains a number of tools which are associated with the tool action. There's lots of different subclasses of tool. Most of the time, the base class is what's used, though. If you just load a random XML file, it's probably going to load using the base class. So this isn't like an abstract interface. This is a base class that has a lot of specific logic in it. But there are some subclasses of it. Setting metadata, for instance, data managers and data source tools both sort of tweak how the outputs of the tool are handled using the output parameter JSON tool subclass. We had expression tools for tools that execute in node environments. Interactive tools were added by Dan Blankenberg et al. Last year, and so these are tools that must run in a container and require a proxy setup that will route traffic from the web client into the container. So like Jupyter, for instance, you can Galaxy will take care of the internals of like, well, this needs to run in a container, the ports need to be mapped correctly, etc. And so the specific logic there is handled in interactive tool subclass. And then the collection operation tools are descend from what's called database operation tool here, like zipping, unzipping collections, merging collections, filtering failed data sets out of a collection, relabeling a collection from a file, etc. But most of the logic is in tool. So how are tools used? How are these things sort of combined? We've got a sequence diagram here. It's probably going to be way too small to see, but I have two actions described here, rendering the tool form and submitting the tool form. And I've got some actors at the top. Let's just talk about rendering the tool form first. So this client here is like everything above the tools controller in that previous diagram, including the web browser, right? But it makes some request that through all that processing magic hits the build method of the tools controller. And what it wants is a description of the tool form to render. And so what the tools controller does, it doesn't use a manager, right? So this is an example of a controller that is doing too much logic and it isn't thin at all. Ideally, there would be a manager here. Oh no, I'm losing my voice. This is terrible. Sort of screaming at my computer. I probably don't need to. But the controller has access to this global app object that has the million things sitting off of it. And so it uses app toolbox as one of them, and it says get the tool from the tool ID that it parses out of the request, and the tool comes back from the toolbox. And then we have a tool. This is an implementation of the tool class that's sitting in the toolbox, and the tool controller calls toJSON on the tool, and it gets a representation of the form back. So this is a description of the inputs, a description of the possible values in the history, current history for the inputs, etc. It's a big, complicated thing. I don't actually recommend using this API endpoint outside the client, but and that goes back to the web browser, and a tool form is rendered. And that's a sort of a simple example of how the controller might talk to the toolbox and the tool. Submitting the tool is a lot more complicated, and there we're going to get involved with some job components, including the job manager and the tool action. So the first part is the same. It's the client initiates some action, and eventually it gets to the tool controller via the create method. That we grab the tool again from the tool ID that we parse out of the request, and then we call on the tool the handle inputs method. And we send a few things. The big key ones are that trans object that we got from the web application, the incoming input parameters, and the current history that we're targeting. And the tool sort of delegates to this execute.py file. It's sort of like, I don't love that. Anyway, execute.py is responsible for, I'll just walk through the logic. It calls execute, the execute method in there, and what it does is it loops over the parameter combinations in incoming. And so it's not just going to execute, I mean, it typically will just execute one job, but you might be mapping over a collection and have many jobs to run, or you might specify multiple input parameters be like executed individually in a single request. And so execute.py is the file that sort of has that logic for walking over parameter combinations and aggregating the results. And so for each of them, it's going to call handle single execution back on the tool. So the tool is actually the thing that knows how to do that. Execute.py is basically responsible for this loop and aggregating its result. What does the tool do? Well, it does a bunch of stuff about validating the parameters, but ultimately, once all of that is done and it's ready to create the outputs, the sort of initial empty outputs and submit the job, it calls execute on the tool action. That calls execute. And the tool action does a bunch of stuff. It creates the outputs. It tells the object store, these are the files I'm going to create. It creates output collections. There's a lot of code that's happening in the tool action. One of the final things that it does, though, for each execution is it enqueues a job using the job manager. And now we're done for this thread. We don't execute the job in this thread. We'll talk more about jobs in a bit here. But it does return that job. It does return that description of that job from the database, the model object. And handle single execution returns that job and its outputs back to execute.py, which is going to aggregate all of those jobs together and send those jobs back to the handle input method and back to the tool controller and back to the client. So this is a complicated piece of Galaxy that I find myself in all the time. Hopefully you're not there, but if you are, this is how the pieces tie together. Each of these methods is pretty complicated, but this is at least how they're pieced together. So now we have a job that the job manager has enqueued, which basically just means the job is sitting in the database. And it's ready to be picked up by a job handler. So these job handlers are, it didn't make the big list of plugins, but there's many different ways to handle a job. I'm going to just describe a typical case, and sort of Nate's going to be mad at me because I'm probably not going to capture all the different possibilities here. But the job handler, yeah, so typically the jobs go into the database without a handler and then can be picked up by a job handler. And once a job is picked up by a job handler, the job handler's job is to watch the job and transition the job states and sort of handle some common startup and finishing tasks. We'll talk a little bit about the job runner mapper in a bit here, but it decides which destination gets the job. And the destination includes which runner lands up with the job. And the job runner is actually responsible for communicating with the batch process or running the job directly if there's not a batch process. But that's that layer that is talking to the things external to Galaxy. So it runs the job and then provides an interface for checking the status of the job. These job runners are an example of inheritance, and there's some custom code loading, right? Because we load these classes directly from the job config. We've got the base job runner. Nearly all of them are asynchronous job runners except for the local job runner, which just runs the job directly. The asynchronous job runners include Kubernetes job runner, Condor job runner, PBS job runner, and then a few different Drama job runners. So Drama is a common interface for talking to batch distributed resource managers. And so you can use this directly in many cases or subclass it if you want to even add additional, like if you want to go beyond the Drama interface and bring some knowledge of the internals of the system you're targeting into play and make the job running experience, better at detecting memory errors, etc. And so Slurm job runner is an example of that, and the Uniba job runner is also. So we mentioned the job handler. Most of the code in the job handler file is actually done in the job handler queue. And what the job handler queue has is a monitor method, which just keeps looping over and doing the same thing over and over again. And what it does is it runs monitor step over and over again. And so you can sort of see this outer loop is just doing monitor step over and over again, essentially. And it does two things. It grabs the unhandled jobs. So if there are jobs that don't have a handler, and this handler can pick up some more, it will assign itself. And then for the jobs it is handling, it will check if they're waiting to be processed. Okay, so it builds a list of the jobs that it's handling and that are potentially ready to be dispatched. Dispatched is a bad word. Potentially ready to run. So it uses a job wrapper. It creates a job wrapper object, and it asks for the job destination. So job wrapper is an abstraction on top of the job that knows a lot more about Galaxy's internals, right? So like we were talking about what belongs to the model and what doesn't. Well, the job wrapper ties the model object job to the rest of the Galaxy internals. So it's a wrapper around the job. Anyway, it's a big, thick object that acts as a proxy towards like operations you want to do on the job. So what's going to happen is going to ask to get the destination, which is going to defer the job wrapper. We'll just defer this to the job runner mapper, which we mentioned, and we'll try to get a job destination. At this point, an exception might be thrown. The job might just not be ready to run, and that's pretty typical. And if that's the case, then it doesn't get to this, job destination is ready. It just will loop back and check again later. But if a job destination is prepared and it's ready to go, then inside of handle waiting jobs, this path will be taken, and it will put it in the job dispatcher, which gives it to the job runner, and then it's the job runner's responsibility to submit it. So I should say the potentially ready to run jobs here are jobs that all the inputs are ready. So the job might be in there well before the inputs are even ready. And so that's what's happening here. There's a ton of logic in this handler file. It's a really beautiful file. It's got the most complicated SQL alchemy. It's handling job limits. It's very complicated, but like really optimized. And so if you're wondering how we can handle, hundreds of thousands of jobs, I mean, it's the optimizations in this file. But yeah, but that's what I mean by potentially ready to run jobs. It means that all the jobs that depend on it are done and all the inputs are ready. But even the dynamic job destination may still say it's not ready. Or job limits. The user may have reached some sort of quota you set up for the number of jobs they can run in a month or something like that. So it still might not be ready. But at this point, when it's handed to the job runner, it actually is ready. Galaxy thinks all the inputs are ready. The admin, if they define custom job destinations, the admin has sort of checked off, like, yeah, there's no conditions that would prevent this job from running. And so the job is ready, and it's handled up to the job runner. And so the job runner has its own queue that looks a lot like this, where it's just going to monitor. It's also going to monitor steps and check the status, but it's the job runner's responsibility at that point. The other big thing the job handler does is it starts up the jobs. When the Galaxy starts back up, it reconnects, it re-grabs the jobs it previously handled and rehandles them and talks to the job runner and makes sure the job runner gets those jobs recovered and monitored again. But yeah, that's jobs. Data managers are a specific kind of job. Any questions about tools or jobs, though? I mean, I guess that's a huge topic. Probably if I was going to keep decomposing the slides, my next thought would be, how do we just take those last couple sections and build their own section around that? But no. All right. No questions? Yeah, that is the first time I've referred to Nate's code as beautiful. It's sort of, I had the analogy, to me, it's like Gothic architecture. That's job handler. It's like beautifully ornate and intimidating and like all these like complicated, I don't know, edges.
Unrelated to that. So Peter Van Hoysten asks, the PBS runner used to have stage in and stage out logic. Is there any general way this is handled? Or is it not a thing that Galaxy plans to do? And yeah, you've answered your own question there. So we don't support that directly in Galaxy and don't intend to anymore. Pulsar is the solution for that.
Yeah, I also have no slides around Pulsar here, but it has its own way of staging jobs. I mean, all of this diagram that I'm on, all of this code would be the same, but the job runner here would now have a bunch of additional responsibilities for getting the job files staged out. And the job, in the case of Pulsar, the job wrapper itself builds up the job description differently too. So it does override the job wrapper and how it does its work with a concept called compute environments. And so it knows what the job will look like on the remote server, and it does all of that. And so it should, in theory, work a lot better than sort of hacking stuff into the job runner, because at the point that you're at the job runner, you already have a description of the command line to run, but it might be different. And so when you actually, so that's why it's important to use Pulsar and override what's happening in the job wrapper. I don't know. It's
Pablo Moreno asks, going a bit back to the loop in the submit tool form, is this part of the code prepared to deal hypothetically with parameter walking, as in a parameter collection construct?
Yeah, and in fact, I think it does. I think the API supports this. I'm sure it's not documented, and I don't think I know it's not documented, and you can't do it in the client. But I think the same thing that lets you walk over a set of data sets would let you walk over a set of any kind of parameter. And so I think it does do that. I think the API already does that. So I think that loop already handles it, frankly. I might be wrong, but those are the execute.py, and the code that calls it in tools.py is in tool init, is the parts of the code that I would touch to implement that. Yeah, I implemented this years ago. I want to say yes, it's just the UI that we're missing, but every time I say it's just the UI that we're missing, we implement the UI and we realize that the stuff I developed was, just concepts in my head that don't work. But I think there's probably even, you might want to look in the API tool tests, there's probably tests around parameter mapping. Yeah. Are jobs, the job wrapper et al. Aware of workflow execution instance that the tool executions and thus jobs belong to? No. Yes and no. It's recoverable, and so there are cases, for instance, the job runner mapper sometimes figures out what the invocation is. And so you could set up a runner mapper that routes all the jobs in a workflow to the same destination, for instance. So that if it needs access to that logic, it can be sort of implemented. I think we have some destinations that do that, like some pre-built sort of dynamic destinations that do that sort of thing. But yeah, there's not. Otherwise, the actual framework itself doesn't really know because it doesn't use that information. Great questions. Yeah, I would also like a scheduler sequence diagram. This would be a fun part, maybe before next year's architecture. Okay, so we're done in what, 10 minutes. Any other questions before I get to the, otherwise I'm just gonna keep talking until we end. All right, Nate, will you interrupt me if there are questions? I think what else we have. Maybe I'll go through, okay, no. Just stick to the slides, John. Stick to the slides. Visualizations are another example of a plugin structure. There's some XML. You can have a template in either Mako or JavaScript, and then some additional static data. There's a whole tutorial about it. I think, unfortunately, all of this this documentation is a bit dated. And so check out the examples, but newer ones that we're adding, we're changing the build structure. And so you'll probably need like a package JSON to get your static artifacts and stuff. So the visualization documentation here is a little dated. Data providers are something that the visualizations can use. And so you sort of can extend data types to provide different slices and filters on data. No one's added a data provider in a long time. So it seems like a really interesting and useful way to extend Galaxy, but I don't see a lot of people doing it unless I'm missing it. So maybe not spend too much time there. Interactive environments, I mentioned interactive tools. They're kind of, interactive environments are like the visualization comparable idea. It extends visualizations with the ability to tie Docker containers in and set up the proxy. I think interactive tools is probably the way to go in the future. So interactive environments probably not something you want to hack on for the time being. A big important concept is the object store, however. So all of those backend components try not to sort of talk to file paths directly, and instead try to mediate access to objects and data sets anyway, through the object store, which has methods like update from file, get data, and get parts of the data. And so this lets us, talk to sort of more exotic data structures than just, or data configurations than just, here's a big NFS server. Like I mentioned before, this is an example of just like an inheritance hierarchy that implements the plugin. The new one we've been hacking on a lot lately is the iRods object store that Kayvon has been doing an amazing job on, and you see a lot of active PRs right now around that. But the interface has kind of stuff you would expect. Does the file exist? What's its size? Touch the file or create it, get the data, get the file name, and update the data and delete the object. A disk object store is just, targets a specific file on disk. The S3 object store, writes things to buckets. And then we have sort of meta object stores. So the nested object store are object stores that delegate to other object stores, including, and the implementations of this are the distributed object store and hierarchical object store. And so the distributed object store is like you have a bunch of NFS, or you have a bunch of object stores, and you might want to sort of send data to them sort of randomly. You want to distribute the data across them. And so you can use the distributed object store configuration for that and sort of tie multiple disk object stores together. The hierarchical object store are in the cases where you only want to write to one object store, but you have some old data. So it's Galaxy, it produces a lot of data, right? You fill up a disk, you're like, okay, I need a new one. And then I'll fill up that one, and then I need a new one, and you fill up that one. Well, the hierarchical object store is what lets you do this. You can sort of say, these are the object stores that you read from, but this is the object store you write to. And so that's where the hierarchy comes from.
Pablo has a visualization question. Yes, do the dependencies for visualization get added to the main set of Galaxy dependencies, or do they have tool-like setup to resolve their deps?
All right, that's a good question. The answer is it's in flux. We're trying to get to a point where, yeah, in the case of visualizations, the dependencies can either be JavaScript things or something in the back end. But if it's in the back end, you're writing a new API or doing a data provider. And so those would just sort of be Python dependencies that we just sort of add to a normal process. And so we just sort of do the normal process for Python dependencies. But for JavaScript things, which is going to be more typical for visualizations, I think what we're having people do now is make sure that all the dependencies are available on NPM and have a package.json file for your plugin. And I think we build those as part of building the client. And so I think we fetch those at runtime. And so I don't think for a long time, we would just ship all of the artifacts for all the visualizations with Galaxy, but that's ugly for many reasons. But yeah, I think what we're trying to get people to do is actually have a package.json NPM description of their plugin. But I would look at the recent visualizations that we've had at Galaxy and look at and what we're doing currently. Because I know we want to do these things. I just don't know if we've documented how to do them or where we are in the process of allowing that and putting that as part of our build process. Does that answer the question?
He said yes, but also has another question about the object store. How far away are we from being able to avoid completely from the shared file system?
I mean, we can.
Yeah,
right?
I mean, right. So in Galaxy proper, you do have to have a shared file system, but Pulsar essentially removes this limitation. And there are deployments, like I think use galaxy.org.au since like the majority of their jobs through Pulsar at this point. So it's definitely not a requirement, but Galaxy itself is not going to solve this problem for you. Is that accurate to say?
Yeah. Also, I mean, we also are making it every year it gets a little easier, right? So this last year we added extended metadata so that the actual Pulsar jobs can talk to the remote object store directly. You don't have to come back to a Galaxy. And I say that was added. I'm sure by next year it will actually work.
Yeah, so Peter Van Hoysten just referenced that, and so there was a demo last year of Galaxy running a job that accessed the remote object store. The limitation was, as he recalls, was no workflows.
Oh, no workflows as in we don't schedule the whole workflow remotely. We schedule the individual jobs remotely. But you can still run a workflow with that. But the cool thing is like, here's a whole workflow, run that whole workflow over there. I mean, it will do that.
I think that's what he's talking about, yeah.
Yeah. I just did the no workflows thing. I just want to make sure, like, you can still run workflows that way. It will just piecewise do that.
Right. Says, has this been developed further? Could I run, for example, a Galaxy server in South Africa and work on data stored in Uganda? And that remembering locality and working and trying to run your jobs near where the data is definitely something that we want to improve on, but it's not something we're doing currently. And it may, I think, depend on stuff, external, object store systems to do that for us to some extent.
I do think that there are active PRs that are improving this process, like the remote metadata stuff, for instance. So, and I do think it's kind of, I know that Marius recently opened something. He was trying to do the extended metadata. So I think it's seeing active work, to be honest. Even if, and it's on our roadmap to do the extended metadata on main, which would presumably improve things.
But I think running the jobs near the data is probably, at least from main's perspective, something we'll solve with iRods rather than something directly into Galaxy. So maybe I'm dreaming too much there. I'm not sure.
Well, yeah, I mean, we better use iRods if we can. Is Kayvon's iRods talk available somewhere? I suppose it's not.
No, in fact, I don't even know if we recorded it, which would be a shame. So we had an internal meeting where Kayvon, who's new to the Penn State team, presented his work, but I don't think we have that recorded.
So the next internal meeting after that, we stopped making them internal. So now we have I should mention this. It's important for the contributing.
Yeah, very good.
We're now having bi-weekly meetings called the Developer Roundtable. Anyone can talk. Just we have a submission form where you just sort of, and it could be any length of talk. So, well, up to an hour. And so if you have like an issue and you have some question, I mean, it's not like a Q&A session, but if you want to like advocate for a position and you have some issue that you want to like walk through in detail and you want developer comments, that's a good way to just submit. Like, the only thing we ask is that you have at least one slide. And so it could be sort of, and sometimes if there's a big PRs now, we'll ask people to like talk about their PRs to the group, and so that we have a lot of people seeing the PRs that are big and have a lot of effects. We've had talks now about the history rewrite, so we're going to rewrite the history in this next release, hopefully. The whole front end around that, the pieces used, etc. We had a talk on the COVID work, and then a talk on cloud launch and GBL stuff, so cloud stuff. But we'd love to have more people talking. It's definitely a place to sort of discuss code architecture every other week. Thanks for the link, Martin.
And we have officially run out of time.
All right. I'll be around in the Discord channel if you have questions. Thanks for everyone.
Yeah, I'm going to have to leave the Remo because I've got to start getting ready for my next session. But I will be on Discord as well. So
good luck, Nate.
Thanks. Thank you, everyone.